特有情况，要不要跟我这样？
去找一下。我觉得我可以试试看过 scope。不是，我第一次试看过 scope。
Okay, the reporter start to present.
Honorable juries and fellow competitors, I'm Sophia from Orion Children High School. Today, I'm going to talk about problem 2, droplet microscope. So this is a problem statement. By looking around a single water droplet placed on a glass surface, one can observe that the droplet acts as an imaging system. Investigates the magnification and the resolution of such a lens. So here's the main focus. First, the magnification of the droplet lens. Second, the resolution of the droplet lens. This is the outline of my presentation. Firstly is the observation, then theory, experimentation, and the conclusion. So we move into the observation first. As this is the equipment setup we use, including a dropper, a smartphone, and an iPad. And this is the observation video picture as we can see. So the iPad, the pixels on the iPad we can see in normal situation. However, when we drop a water on the iPad, we can see the each pixels clearly. It means that the droplets can work as a microscope. So this is the droplets of the sample. Here, I want to define the radius of the droplet. That is the maximum radius plus the minimum radius divided by 2. Then is the theory. First is the length equation. Here we define the RO as the object distance, the RI as the image distance, and the F as the focal length, and the W is the thickness of the droplets. Then is the theory about Newtonian formula. And here we define XO as the distance between objects and focal length, XI as the distance between image and focal, and then F means the relative index. And here, because our object is put in front of the local plane, then so it will form a magnified virtual image. So we have to change this into a plus. It means the F squared equals to the F minus the RO multiplied by F plus RI. Then is the length matrix equation. And here I want to clarify that we assume our droplet as a thin droplet. And here we define the R1 as the curvature radius of the curvature radius far from the objects. And R2 is the curvature radius near the objects, and N is the fracture index. And here, because we use water, so it is equals to 1.53. And here, because the R2 is a straight line, so the curvature radius of R2 is infinite. So we can ignore it here. Then it's the resolution of the calculation. Here, R means the resolution of the image. N dot A dot is the numerical aperture, and the lambda is the wavelength of the light. And here, according to the equation, we can find there is no clear correlation between the R prime and the formal length. So theory in summary, the above list including N, RO, W, big R1, big R2, big H, small h, lambda, and alpha. That is we already know. And by big H and small h, we can get to know the N. By big N and RO, we can get to know the RI. And by the RI and RO, we can get to know the F. By RO and F, we can get to know the XO. And by RI and F, we can get to know the XI. So this is all of our calculations. And about the experimentation, so we firstly drop loss on the iPad. Then we change the picture into grayscale, and we correction the length units by image J. Then we measure the pixel's length by measuring the distance between two white lines, which makes this a pixel, like this. So here's the curvature radius, how we calculate. When the contact angle of equals to 90 degrees at this point, we can use the formula to calculate the curvature radius. And when the contact angle is not equal to 90 degrees, we have to use this formula to calculate our curvature radius. And in my first experiment, I want to check my independent variable is the average radius of the droplets. So according to the first equation, we can get to know that the R1 is proportional to the volume. And according to the second formula, we also found that R1 is also proportional to the focal length. However, because RO is a constant, because we didn't change the RO, so we can found that RO is inverse proportional to the. We can found that F and V are negative relation. So as the chart you can see, it is negative related. Then it's my second variable. It is the volume of the droplets. So in my experiment, when the contact angle is 90 degrees, we use we can by the first formula and by the second formula, and we can find that F is proportional to the R1. So here is our theoretical value and experimental value, which is really matched. So we will get into the conclusion. Firstly, the droplet volume and magnification are negative relation. Then F is proportional to the R1. Third, there is no correlation between droplet volumes and the resolution. So this is my presentation. Thank you for listening.
Okay. Question from the opponent.
My first question is, how do you get the R1?
We use this formula if the contact angle is 90, and if the contact angle is not 90, we use this.
And under X is your magnification is angular magnification or transfer magnification.
Pardon?
The magnification, the thing that's not red. You use is angular or transfer.
I'm not quite sure.
The transfer magnification is the things that actually red larger. Actually red.
Can you explain more?
See. And you know more resolution definition. More resolution definition.
Again.
The resolution can be defined in many.
Actually, we didn't do the experiments about the resolution because we met some difficulties, so we calculate by the theories.
Okay, opponent take 4.
Here's a problem statement. By looking for a single water droplet placed on a glass surface, one can observe that the droplet acts as an imaging system. Investigate the magnification and resolution of such a lens. Here's a summary of the report. The theory they use is Newtonian and lens maker equation, curvature calculate, and the experiment they made is dropper, iPad, iPhone, radius of droplet, and volume of the droplet. Here's their strength. The complete positive phenomenon explanation allows of the experiment to prove and their assumption. Then the suggestion for them is lack of quantitative. No mesh theory and model droplet not length. Didn't clearly definition. And let's begin our discussion. Let's go to that core. Can I use that core? Do you know what's exact the droplet shape?
It's contact angle where inside the droplet is, but because the contact angle depends on how clean the surface is, so we clean the surface very clean, so we think we can control it well. And also we use the MHG to check whether each droplet is similar or not.
But on my learn, the contact angle is used to capture the droplets. It's not the thing that define the droplet shape. I think the thing that influence the droplet shape is about the delta P here, and maybe it's how much volume you use to experiment the volume of water.
10 millimeter and 12 to 10, 12, 14 to 30 from 10. amount of water is the same, and also we have clean the surface. So I think that shape we control it really well because we believe the shape is the main parameter which influence the focal length.
But have you ever tried to use more of water in your experience? More than 100 ml?
Actually, we use because of the surface tension and other reasons. So when we use more volume, it will not like be a single severe. It will not might be a severe. It will might like this. So we can calculate for that situation. So we just calculate to 30.
But I think, although if you use more than 100 ml, it also can be the curvature here is also can be calculated in your patent, right? And so maybe you can do in your review.
Okay, I also believe that.
Can I ask you how the detail of your experiment that you're measuring your resolution expertise?
Actually, I didn't do the experiment about the resolution, but as those I can share with you is that I think we can find a paper that has from big to small, and we can check at the droplets and to see how small we can see and to calculate for the resolution.
And ask you, how will you if you didn't have an iPhone or iPad?
Actually, we didn't use iPhone. We just use iPad, and another phone is not iPhone because iPhone have autograph, so it will be bored sometimes. Okay, about the iPad, actually, I'm not quite sure. Do you want to suggest me for something else? Because I think iPad is quite well because it's fixed, so we already know how long is the pixel.
And I want to ask you, how do you know the distance between the pixels?
It is the same.
Oh,
Just no matter which brand or which it is the same.
and how to talk about the resolution. You said resolution pattern is like this, right?
Yes.
And your what's your measure is the neural aperture.
Could you ask again?
I would ask you the definition about the resolution.
Okay, so the definition of the resolution is that 1.61 multiply the lambda and divide by n and the sine alpha.
I think in another sentence like this. The D is the things that the median distance that the two things can be.
Yes, so if the two things can be known that is different, I think it can be the resolution. We can find the minimum, so we can clearly see it is different.
I want to ask you about the if the variable is the radius of the droplet flow. You said your variable is the droplet radius, right?
Yes.
And hold on.
Okay.
When you change the gears,
In our conclusion that if the volume and the magnification are negative relation.
you say,
So if the volume is bigger, the magnification efficiency will be smaller.
and I want to ask about you know, have you tried the pixel resolution, the resolution of the pixel? The thing you get,
Use risk pixel to measure the magnification rate.
what's the resolution of pixel? No,
No,
pixel.
I'm not trying for that actually.
You know, your guys experience is used to chop the and make it more like a.
Like severe, yes.
And how do you sure that it won't appear the situation like your chocolate is a little bit like this?
Actually, firstly, we use dropper, so the dropper will let the droplet very accurate. However, we still will have some shapes not so severe. For example, it is rectangle or outward. So whatever. So we will choose the data. We will choose the most near the severe one. Yes.
And I want to discuss about if you change the plastic here, and what will happen to the resolution and what will happen to the droplet shape?
It will affect the droplet shapes a lot because I think the angle depends on the material. The material will decide how shaped it was.
I want to know if the droplet is like this shape, you know,
Yes.
and how will you measure the resolution and accuracy of this?
Maybe I will change our equation because this will have a height. But the equation I use can calculate for the height. However, maybe I think the double length equation might fit this situation. I want to try to calculate by use double length. Consider it as a double length.
I want to explore that. Have you tried to use another liquid that is not water?
Actually not, but I think that fracture will be different. So also the magnification will be different.
Summarize.
I talk about some another variable that may change the resolution and magnification, like change the plastic of the ground or increase the balloon there or use another liquid. And we also discuss about their way to find out the resolution. Here's my summarize.
And then for the reviewer's question.
Hi, I'm the reviewer, and I want to ask the opponent, do you agree with the reporter about using lens maker formula in this phenomenon?
I'm not really agree because the droplet is still it's not a perfect lens.
So does the reporter have any fix on using a lens maker formula? Because
Because in our theory we assume it is a thin sphere, not a thick sphere, so we ignore the height.
okay. And I want to ask I want to ask the reporter, what is your definition of magnification?
So the definition of magnification is the original height and the new height divided by the original height. The new length divided by the original length of the pixel.
I want to ask the opponent. In the conclusion of the reporter, he said the magnification and volume has negative connection. And do you agree with the reporter?
Maybe in their range of experiment, maybe it's right, but I can sure that it will be the same if I change another if I explain the experiment.
Okay. And also in the reporter's conclusion, she said that there's no correlation between the volume and the resolution. And do you agree with that? So you think there will be a correlation between these two factors?
Yes.
Okay. And what would be the connection be like, the volume and the resolution?
Because the volume and the resolution of because as the water balloon increase, the height of the droplets won't be higher. Yes, and the curvature will become small, and also the magnification will be bad.
Okay. I want to ask the reporter, do you consider the immersed depth in your model?
No.
And do you think you should fix it, because I think it will have some effect on the results?
Yes, actually, I also agree with your opinion.
Okay. Do you think she should consider immersed depth?
Okay, time's up.
Thank you.
Okay, guys up.
Okay, hi, I'm the reviewer from Team Relativity. And the problem statement is, by looking through a single water droplet and investigate the magnification and resolution for such a lens. So, in her theory, she uses lens matrix formula and the Gauss formula for its equations, and then calculate the resolution, and then about its volume and focal length. And in her setup, she uses lens, dropper, iPad, and phones, and then the parameters is the droplet radius and the volume of water. And the report, I think she has a complete quantitative phenomenon explanation, and she explained this in a simple way, but I think the measurement could be improved, and the theory and the model is not correct because I think there's something wrong with the theory, and then I think she needs to clarify the definition of resolution and magnification in her presentation because it's very important in this problem statement, and then she has no experiment on the resolution yet. And the opponent, I think he knows how the different definitions will affect the statement, but I think he has a too short remark and a bad time control on the summary of the report, and he doesn't know how the droplet would be like on the surface. And then here will be the discussion part. So the opponent asked the reporter, what's the definition of resolution? And the reporter said, she don't know. And I think she should tell us the definition of resolution because there are different kinds. And then also she maybe do the experiment to further prove it. And then also ask the definition of magnification. And the reporter is also not sure. And I also think it's an important part in this phenomenon. And then what opponent asked, what happens when there's too much sphere? And then the reporter said it won't be a sphere. But I think she could maybe find a way to tell us the relation between volume of water and shape. And then he asked, how do you measure a distance between the pixel? And the reporter said it will be the same. And I also agree because on the screen the pixels are the same distance, but maybe you should tell us the real how much. And then the opponent asked. Also, and in later discussion, the opponent asks what's the definition of resolution, and then she tells the correct one, which is optical, and I think is good. And then the opponent asks how does the surface material affect, and then the reporter said it will affect the angle. Yes, so I think if you change the surface material, the droplet shape would be changed also. And then the opponent, and then I asked the reporter, is the usage of lens matrix formula correct? And I think she said she could use it in her theory, but I think it's not because lens matrix formula needs to be two circles to use, and it's not in her model. And then the opponent doesn't agree with the reporter, which I think is correct here. And then I asked the opponent about the correlation between the volume and resolution. Yes, and I think it will also affect. And then I think these are the missed points in the discussion. So she should consider apparent depth, and apparent depth is when you look into another substance. The looks of and the real item will be different, and then she doesn't consider it in a theoretical model. And then also she should define all her resolution and magnification in her presentation because there's different kinds of maybe like 2 types of resolution and 3 types of magnification, and that's very important on clarifying how this problem statement works. And that's the end of my presentation.
Okay, we move on to the next stage for the concluding remark.
So this is my concluding remarks. First of all, we did say the definition of the shape of the droplet is the same because the surface is clear and the same. And second, the volume becomes bigger, the magnification will become smaller. we choose the severe one to analyze in data. So the severe will make sure that each one is extremely similar. And the fourth, we think the difference of the liquids will cause the fractive index be different, so it will influence the results. And five, we did talk about the definition of the magnification. That is the new length divided by the original length of the object and the image. And the sixth is that we will consider the image that appearance that in the future. And this time I didn't consider it. It is because we think the glass of the iPad is extremely thin, so we ignore it. But however, we did agree with one of two that it is have to be considered. So this is my report. Thanks for both opponents and the reviewers.
So any question from the
Question to the reporter. You were talking about some theory whatsoever, and you define magnification. Theoretically, could you tell me what is the maximum magnification in your system?
0.18. No.
Less than one is not magnified. No, I was asking what the maximum magnification you can achieve with your system. Well, maybe that I can invite the opponent to answer first.
The maximum magnification.
Based on her theory whatsoever.
It should control the corner balloon of the.
Well, then we invite.
Yes, in magnification there's three definitions. One is longitudinal, transversive, and angular. And I think the angular, the angular definition of this magnification could find the best, biggest magnification in this case.
What's the maximum? Give me a value whatsoever. Say 10, 100, 1,000, something. With her system. You remember what was the value, the magnification she came up with?
But I don't know
You
if
didn't
the experiment is correct.
No, I was asking the number she showed.
Can I guess two?
Sure.
2 times. Maybe 2 times. 2 times bigger. 2 times bigger.
Okay, I'm done. Oh, okay.
Due to the volume of image distance, it wouldn't be infinity.
Then how come she only came up with what? What was the number, you remember?
I don't.
See? That was 3 point something, right? Am I right?
Yes.
And how come? Yeah, 3.5 something. As far as I remember.
It will be based on like the parameters. It will be different. Like in different parameters, it will be different, but it will not be infinity due to the value of image distance.
But tell me what went wrong with her system.
But I don't know what her parameters are like.
Well, you listen to I think that's fine.
And can all of you give us a comment about the effect of the gas?
It's a immersive depth that I showed in my presentation. So it would make you look at a different place even though the object is not there.
Okay. So how about you?
If there is a glass under a droplet, I think the magnification there major will not be occur.
The glass fractive index is not the same with the water and the air, so it will cause the deviation.
So how about the interface effect between the droplet and the gas? I mean the interface effect. Yeah. Okay.
Answer. The thing that's this the contact angle, influence the contact angle is the force between water and surface, and the force between water and gas, and the force between gas and the plastic article.
And review.
Yes, it will affect the surface tension between of the droplet, and you could use Young's equation to know like the surface tension and gas.
And we agree with the reviewer.
Okay. So any other question? Okay. The score of the reporter 55645, and the score for the opponent 54445, and the score for the reviewer 77567.